We'll be looking at repeated questions that are a bit dicey. We started 30 minutes behind schedule. Sorry about that. But what matters is that we are here now. So let me share the link to the group. Okay, we are back. We are back. The questions we had through the week, we'll be solving them here. For some of the questions we had in chemistry biology, we'll start with chemistry first and then go with biology. The questions are biology. Okay, yeah, the one we have here, question number 1 says that two gases A and B diffuses through a small hole. If gas A has molar mass of 4 gram per mole and gas B has molar mass 36 gram per mole, the ratio of rates of diffusion of A to B, the rate of diffusion of A to B, that's the ratio of the rate of A to B is, here most people will go straight forward dividing 36 by 4, and with that you will likely get 9, which is incorrect way. First, you need to use Graham's law of diffusion, and under that law we are expected to follow the mathematical representation of Graham's law of diffusion. So using Graham's law of diffusion, this law states that R1 over R2 is equal to square root of M2 over square root of M1. To relate it to the question we have, instead of using 1 and 2, let us use A and B. RA, rate of diffusion of gas A over rate of diffusion of gas B, is equal to square root of molar mass of gas B all over square root of relative molecular mass of gas A. Simple. They are looking for this RA to RB. That's the question, what the question said. Maybe for those joining, I got to bring this out so we can see. This is actually the question I'm solving. Two gases A and B diffuses through a small hole if gas A has molar mass 4 gram per mole and gas B has molar mass 36 gram per mole. The ratio of rates of diffusion of A to B. So, and then remember, we already have the RA no need of trying to change it. R over RB equal to square root of MB. From the question, the molar mass of the second gas is 36. So is equal to square root of 36 over the molar mass of the gas A. They said it's 4 gram per mole. So you just say square root of 4. Therefore, if you look at this, square root of 36 is 6. And square root of 4 is 2. 6 is to 2, which is the same thing as 3 is to 1. So the correct answer is option B. The rate is 3 is to 1. Some that we're getting 1 is to 9 or 9 is to 1. No, you are not to. The law did not say that the rate of diffusion is directly proportional to the relative molecular mass. No, the law did not say that the rate of diffusion is inversely proportional. Sorry. to the relative molecular mass. No, to the square root of the relative molecular mass. So you then not just did 36/4. No, it's the square root of it. So the equation is well constructed. Remember to ask your own questions there in the comment section. The next question says, which process is always endothermic? The process that is always endothermic, meaning process that involves the absorption of heat, that is colder to touch. How to know it is that any reaction that is always endothermic needed energy, must need external supply of energy before it could happen. So neutralization releases heat, as we know. So neutralization is exothermic. Combustion, of course, burning something releases heat, and any process that releases heat should be exothermic. Then bond formation, when bonds are formed, they release heat. But bond breaking requires energy. For you to break something, you need to add energy to it before you can break. You need to apply force. So the process that is always endothermic, looking at this question, is option C, which is bond breaking. So bond cannot just break on its own. You need to add energy to that. Then the next question says the monomer of polyvinyl chloride. Polyvinyl chloride, we know it popularly with the name PVC. Polyvinyl chloride. So PVC pipes, PVC ceiling. So looking at this, vinyl chloride means vinyl chloride. Vinyl chloride is the same thing as chloroethene, right? So chloroethene is vinyl chloride, which is CH2 double bond CHCl, which rhymes to option B. So that is the monomer that builds it up. Then remember, we'll answer from 1 to 13. We are here will be 5. We'll continue in another page. Which reaction converts benzene to nitrobenzene? Nitration of benzene converts benzene to nitrobenzene. So in this case, hydrogenation doesn't do that. Then Friedel-Crafts alkylation, no, it doesn't do that. Then reaction with concentrate, yes, of course. This acid mixture is what we call nitrating mixture. So this acid, HNO3, concentrated HNO3, about 90 something percent, of course, not the regular one in the market, with H2SO4, forms the nitrating mixture. That's what we use to introduce the nitro compound in the benzene ring to form nitrobenzene. So this is done while making your toluene, trinitrotoluene, and the trinitrobenzene, TMB. These are explosives. The number 5 question says, exchanging two alkyl groups in ethyl ethanoate gives exchanging the two alkyl groups in ethyl ethanoate gives what? First of all, we have to write the formula of ethyl ethanoate. Remember, that is ester. Ester is ethyl ethanoate. They are asking us exchanging the two R in this compound, ethyl ethanoate. You have to write this compound correctly first. Ethyl ethanoate. This is R. This R came last. Et means 2. So C2H5. Always write et means 2. Write the whatever that is here first. Write it last. And at the back, you write OO. And then C. What is in front is also et. This is et, which happen to be 2 carbons each. So this et is 2 carbons. This other et is this carbon here. This is the R. We have gotten one R. This is an alkyl group. Then the next R should also be et. And et means 2. So out of that two, this one carbon has collected one because it will also count. So we are left only with one. So that we have now CH3. So this compound is what? Ethyl ethanoate. Ethyl 1 plus 2 ethanoate. So this last R is named to alkyl, while this first R is connected to noate. All right. So this is the ethyl ethanoate, and what are the R's? This is the R. These two are the R's. So exchanging them, bringing this one here and taking this one here. Let's go. What will it be? C2H5. COO is constant. COOCH3. So I've exchanged it. What's the new compound? Remember in ester, you named this last R first. And what's the last R here now? One carbon. And one carbon is met. Therefore, this is what? Methyl. Then here is two carbons plus this one, giving it 3. Propanoate. So when you exchange the two R's in ethyl ethanoate, you will get methyl propanoate. So looking at that, let's see which one rhymed correctly. That is option A, which says methyl propanoate. For those live, you give this live stream thumbs up and share it also on your platform. Share it with your friends. We are moving into question number 6. Remember to send your own question in the comment section, or you can also send it to Daily Science Quiz. Daily Science Quiz 4 at gmail.com. Let's assume your question is coming with pictures. So when you send it, you also alert me here on the comment section telling me that you have sent a question. Let's assume your question involves graph or drawing. You cannot type it there in the live chat. All right. Remember, you're on with the Majestic Tutorials, your free school within school, after school, and then your complete online school. So we move to the next slide, if I might call it that. Question 6 to 13. Looking at this question, we'll be careful. They are there to expose you, and these questions repeat often, and when they repeat, student finds it difficult. Please share this video and give it thumbs up. For those that are live, you can still say hi. I need to know you're there. I'm sure I didn't turn off the chats. All right. This question says a radioactive nucleus emits a beta particle followed by an alpha particle. The final nucleus compared to the original will have what? What will it have? Your job is to know which one is beta and which one is alpha. How do we represent beta particles and how do we represent alpha particle? And then you should know what we call alpha decay and beta decay. What happens to the atomic number and the mass number when a radioactive nuclide undergoes beta decay, and what happens when it undergoes alpha decay. Let's go. We will consider beta decay first. That's the one they mentioned. Beta particle. What is a beta particle? A beta particle is equivalent to electron, fast moving stream of electron. So we put minus to show it's negatively charged as an electron. Then electron have mass which is negligible, mass unit of 0, and a charge of -1. So here is a pure representation of beta particle. So if a radioactive isotope emits this, oh, okay, Perez, how you there? How you there? Yeah, you're welcome there. Thanks for joining. You can share on your own status. So beta particle, looking at what is here, when a radioactive nuclide emits beta particle, it will increase in atomic number. This sounds somehow, and nothing will change in the mass number, because beta decay actually means changing a neutron to a proton. When a radioactive isotope undergoes beta decay, it means that there is a swap between neutron and proton. So a neutron is converted to proton during beta decay. That's why what I'm trying to say is that if this is a radioactive nuclide and what is here is 4, what here is 10, if this nuclide undergoes beta decay, it will give us a new element, Y, that will have 5 here and 10. Nothing will change because this is 0. Why will it have 5? One of the neutrons here, remember this element has 6 neutrons and 4 protons. 4 plus 6 gives you 10. One neutron here was converted to a proton, and hence when a radioactive isotope undergoes beta decay, its atomic number increases by 1 and nothing happens to its mass number. The mass number remains the same. If we look at this, we have that, okay, the question was constructed well, that the thing emits beta particle followed by an alpha particle. On meeting beta particle, nothing happens to the mass number, but the atomic number increases by 2. Now, when like this, the atomic number increases by 1, not by 2, by 1, please. When I use what I have here on the screen to explain, that means let's take it is 4. It will now become 5. When it becomes 5, it will now emit alpha particle. Alpha particle is equivalent to helium nucleus. Right? Is equivalent to helium nucleus. So it is 5 now. If it emits this, what should be 16? We will minus 4 from 10, it will remain 6. And we minus 2 from 5, it will remain 3. Remember, this is the original nuclide. So we will use this to answer that question. It means when it emits, what happens? The mass number decreases by 4, while the atomic number decreases only by 1. Why? Because it will increase by 1 and now remove 2. At the end, minus 1 plus 2, it's still plus 1. So option A says atomic number decreased by 1, correct, and mass number decreased by 4. It is A that is very, very correct here. Option A is extremely correct. Atomic number increased by 1 and mass number decreased. Okay, option A and B was mistakenly typed as 1. Is looking exactly the same, but that's not what it's supposed to be. Then look at this error. Don't mind the error. This is not how I constructed our in the course of transmitting like this. Atomic number increased by 2. No, not at all. So something is not well with that option. Option A is the right thing. Other options were meant to be wrong. Okay, if I can lift the original questions, we'll see what is there. The next question says, we'll take a break. Remember, you're on with Majestic Tutorials. You can order for your laboratory equipments and reagents. I deliver on time any part of the nation, any part of Nigeria. If you call us, we answer you. One good thing from buying with us, one good thing that you buy with us is that the person that is selling to you is a scientist. He knows the value, the actual content of what you are buying. When you're having challenges doing practicals, definitely you call on us, we guide you properly, whether you're buying for lab or for medical things. So Easy World Science and Surgical Supplies has come to cover you up, right?
Advert. Buy from me, I equip laboratory, standard laboratory. I give you trusted reagent because scientists equally medical equipment. Thank you. Your patronage is needed.
Looking for experts in building and equipping standard science laboratories?
Need reliable surgical or hospital equipment? Easy World Science and Surgical Supplies Limited is your best choice for quality and excellence. We provide professional construction of standard science laboratories, high quality laboratory equipment and reagents, durable surgical and hospital equipment, timely delivery of exactly the quality you request, expert guidance to assist you with any experiment or equipment usage. Be scientific, stay safe. Choose equipment and reagents that guarantee results and protect your health. Contact Easy World Science and Surgical Supplies Limited today. Majestic, reliable, affordable. Thank you.
Majestic Tutorials, your free school within school and after school, your complete online school.
Majestic Tutorials, your free school within school and after school, your complete online school.
JAMB with a high score and earn straight A1 grades in all 9 WAECs. Want admission into medicine and surgery, law,
Pharmacy,
engineering, nursing, architecture, computer science, accounting, dentistry,
medical laboratory science,
and many more lucrative university courses.
Then join Majestic Tutorials on YouTube and across all social media platforms today.
Enjoy world-class lessons in all major art and science subjects, completely free.
Delivered by experienced and renowned tutors. Don't miss our live streams, final revisions,
and exclusive study sessions. Call or WhatsApp +234 706 5166217 to join now.
Majestic Tutorials, where champions are made the majestic way.
All right, let's display the questions. You're welcome back. These questions are there. Check your ability. The next says the half-life of a radioactive isotope is 10 days. What fraction of the original sample remains after 30 days? What fraction of the original sample remains after 30 days? How many half-lives are there in the duration of the time given to us? This is a direct reasoning. The half-life, of course, is 10 days. So in 30 days, you simply say 30 divided by 10, which is 3 half-lives. And then for you to know the fraction, you say 1, because half-life is time taken for the original to decay half. So 1 over 2 raised to power 3, which is 1 over 8. So the fraction that have decayed, the fraction that have decayed should be 7 over 8, such that the fraction remaining should now be 1 over 8, which is option C. So this is very simple and straightforward. Just divide the duration given to you by the half-life, then say 1 over 2 raised to power, whatever you get as your answer, gives you the fraction of the one that the sample that remains. They say, which of the following compounds will exhibit optical isomerism? Optical isomerism is exhibited by compounds or molecules that possess at least one chiral center or one stereogenic center. There must be at least a chiral carbon. Chiral carbon means carbon that is connected to 4 different species. Like if we have this carbon connected to X, connected to Y, connected to V, connected to G, then this carbon is a chiral carbon. Why? Because there are 4 different groups connected to it. So if a molecule doesn't have one chiral center or one stereogenic center, such molecule is referred to as a chiral and cannot exhibit optical isomerism, and is exhibited in by molecules that form mirror images of one another, such that one will rotate the plane of a polarized light to one direction and one rotates it to the other. So we have the one that rotates to the left and the one that rotates to the right. The one that rotates to the left is called the lavio, and the one that rotates to the right is called the dextrose, or the plus and the minus, of course. So if you have to expand, assuming these options were typed correctly, if you have to expand this whole carbon and find out which one have connection to different four groups that have at least a chiral center. So we are going to take it gradual. We will hold it and bring our note here. Take the option A, one after the other. I'm doing this because I'm teaching. If not, I would have gotten I'll just tell you the answer, but I'm now teaching you how to get the fish and not giving you just the fish, so that next time you go fishing alone, you'll be able to catch by yourself. So the tutorial is meant to help you score 370 and above in this forthcoming JAMB. Anytime you come across this live stream, please subscribe and share with others. All right, then we are expanding this one. This is CH3, which is this. This is CH2, which is this. Then CH2 and then OH. So there is no chiral carbon there, no chiral. So this molecule is a chiral, and since it's a chiral, that's it cannot exhibit optical isomerism, because this carbon, for example, is connected to 1, 2. Hydrogen and hydrogen is the same. So when two atoms are connected to that carbon, one carbon, two atoms that are the same, such carbon that bears them cannot be chiral again. If you look at this one, it's connected to 1, 2, carbon versus carbon, hydrogen, so it's not a chiral. So this one cannot. So we go to the next option, which is option B. Let's expand well. C, we have C, H3, C, H, and then OH, anywhere you like you put it, and then CH3. This is no more a chiral carbon. Why? There is no chiral center. So this is CH3, is also the same thing as CH3 here. Carbon, carbon. So this cannot exhibit. Looking at D, C will not exhibit. So let's not waste time there. D, let's check D carefully. D might probably exhibit it. All right. D should be the correct answer because I'm seeing it already. Let's expand. CH3 is this. And then we move to CH and Cl. Then from this, we move to CH2, CH2, which is like this, and then we continue moving to CH3. So we have one chiral center here. This is a chiral, this molecule is chiral molecule, so it can rotate the plane of a polarized light. A chiral means when a molecule don't have a stereogenic center, when a molecule lacks a chiral carbon. Chiral carbon, chiral, I said it in the beginning, is carbon that is connected to 4 different substituent groups. Let me take lactic acid to demonstrate it. 1, 2, 3. So we have here, this is COOH, and here is what? OH, here is H, and this is CH3. So if you look at this carbon here is chiral. Why? It's connected to four different. Look at one COOH. There is no other group that is COH that is connected to this particular carbon. I'm considering this. Then there is OH. OH is different from COH. Then there is this H. H is different from OH and COOH. Then there is this CH3. So 1, 2, 3, 4 are all different and they are all connected to this. So this young man now is a chiral center. So we can call it chiral center or stereogenic center, though chiral center and stereogenic center are not actually, they are not exactly the same, but sometimes we can synonymously use them. All right. So but here, so this particular molecule now is equally active. It is very much active. Why? Because there is at least one center. Remember, I said at least one, which means if it can become more than one, thank God it's going to have it. It's going to be optically what? Active. So the condition for a molecule to be optically active for now is that there must be at least a chiral center. And in other words, they should not be meso compounds also, because meso compounds will still cancel the chirality somehow. If they are mirror images that are superimposable, it will not have, it will be a chiral. Now, back to the thing now. Relating it to what I have here, look at here. This is, okay, yeah. Relating it here, this is C. Let's consider this particular carbon. This particular carbon is a chiral carbon. Why? Because C2H5 is different from CH3. Chlorine is different from hydrogen. So there are 4 different substituent groups. And that 4 different substituent group makes it a chiral. Therefore, the answer to this question is D. That's the only one that can exhibit optical isomerism. All right. For those that are live, we wish to draw the curtain here. Something we have to fix it. Next week by the same time, we'll continue. Remember that there are packages. This learning is a continuous process. As you enjoy it now, there are people that are already engaged. Check any of these packages, the one you can pay for, and enjoy your private tutoring. It will benefit medical students more, because I'll be handling you more in biology and chemistry. There, you will make up to 90 something on in each of these subjects if you participate in any. Look at the packages. So you're advised to look at B and A, because if you subscribe to either ED, you wait so that the class will be complete. But the class of C group B, you just need only 2 members. Let's assume you cannot afford 65,000 naira per month. You can now afford 30. We are just pay you with another student. You will have your own private timetable and unlimited time to ask unlimited question access. Anytime you are reading, you send in your question, I will attend to you. We will draft our timetable. We'll give you your personal weekly assignments, of course, to assess how far. We do our CBT weekly to know how far you have gone. So the mentorship continues. It's an intensive program. So watch any of this package and then chat me with the number you see here on the screen, 070 if you are chatting within Nigeria, 07065166217. But if you're outside, you put +234. That's our area code. And then make sure you don't pay to any other person in the name of me. Confirm the name before you pay. Remember that fraudsters are everywhere impersonating as me, but they are not me. So these packages are available. The earlier the better. Let's give you that score you need. That 370, that 330, you need to go for your medicine. Majestic Tutorials, we are so much made experienced to give you the best. Okay, so thank you for participating in today's live stream. We'll see you next in the next Friday by 8 p.m. Though we started that off today lately, but next week will be not. I will be there on time. Your job is to tell your friends about this 45 minutes free live stream that happens weekly. All right. So these are the questions we handle. Before we wrap it up, we answered this question you are seeing on the screen. I explained it well, solved it for you. Then down to number 5, and we now continued here. So at least we handled up to 9 questions. All right. In our next live stream next week, we will continue, and if viewers turn up, we will do both chemistry and biology. Thank you for those that visited. I wish you all the best. Good night.